Okay, now we're going to use half angle formulas. And for example A, we need to use the half angle formula for cosine. And the half angle formula for cosine is u over 2. So you have an angle u and it's cut in half, which is why it's called half angle formula. And that's going to be plus or minus 1 plus cosine of angle u all over 2. Now that 2 is under the square root, so make sure you keep it under there. So in order for u over 2, this to be equivalent to 112.5 degrees, that means u is going to have to be 225 degrees, because I would multiply both sides of that equation. U over 2 is equal to 112.5. I would multiply both sides by 2 and I would get the angle u is 225. So half the angle is 112.5. The other thing I want you to notice is that we've got plus or minus depending on what quadrant we're in. Since we're trying to find the cosine of 112.5 degrees, that's in the second quadrant. Cosine in the second quadrant is negative, so we're going to use the negative square root. So I have cosine of 225 over 2, which is the 112.5 degrees, is equal to negative square root of 1 plus cosine of u, and u we said was 225, all over 2. Well, if I look at my unit circle, the cosine of 225 is negative square root of 2 over 2. So I have 1 minus the square root of 2 over 2 all over 2. Now, we can't leave it with complex fractions under the square root. So I'm going to multiply inside the square root. I'm going to multiply the top and the bottom of that fraction by 2. That way I clear that complex fraction. So when I multiply the 2 by the 1, I get 2. And then 2 times the square root of 2 over 2 just gives me the square root of 2. And then 2 times 2 in the denominator is going to give me 4. And then the last thing I can do actually is pull that 4 out from the square root and write it as 2. Because the square root of 4, if I take it outside the square root, would be 2. Okay, in example B, we're taking the sine of 11 pi over 12, and using the half angle formula for sine, our formula for half angle of sine would be sine of u over 2, your half angle, is equal to plus or minus the square root of 1 minus cosine of the angle u over 2. So we got to figure out what angle u is if u over 2 is equal to 11 pi over 12. I would multiply both sides of the equation by 2, and I would get the angle u is 11 pi over 6. So I would have sine of 11 pi over 6, which is u, all divided by 2, is equal to, and I would have the square root. Now I have to choose if it's plus or minus. If I look at 11 pi over 12 on the unit circle would be in quadrant 2. In quadrant 2, sine is positive, so I want to make sure that I use the positive square root. Then I want to take 1 minus the cosine of 11 pi over 6. And the cosine of 11 pi over 6 is the square root of 3 over 2. And that's all over 2. So now I'm going to multiply underneath the square root. I'm going to multiply the top and the bottom of the fraction by 2 so I can clear my complex fraction. So that would give me 2 minus the square root of 3 all over 4. And then my last step is I can take the 4 out from under the square root and write it as 2 minus the square root of 3 all over 2. So this is my final answer for sine of 11 pi over 12. The next example says if cosine of angle A is negative a half and A is in quadrant 3, find sine of angle A over 2. So we need to find sine of A over 2 using my formula plus or minus 1 minus cosine A all over 2. Now to choose whether it's plus or minus is tricky because we have angle A and we have angle A over 2. What we're trying to find is the sine of angle A over 2. So I need to know what quadrant A over 2 is in. So since angle A is in quadrant 3, here's a trick to figure it out. Angle A is in quadrant 3. That means angle A has to be between 180 degrees and 270 degrees. And if I divide that whole compound inequality by 2, I get that angle A over 2 is between 90 and 135, which means angle A over 2 has got to be in quadrant 2 if angle A over 2 is between 90 degrees and 135 degrees. So angle A over 2, if I take the sine of A over 2, the sine in quadrant 2 is positive. So I now know I'm going to erase plus or minus and just leave the plus. I'm using the positive square root in this case. So I have the square root of 1 minus cosine of A they give us is negative a half. Be careful with those double negatives. There's a minus in the formula, and then cosine is also negative. So I have 1 minus a negative a half. That gives me 1 plus a half, which is 3 halves. And when I multiply everything by 2 to clear the complex fraction, I get the square root of 3 over 4. And I can take the square root of 4, and I'm left with just the square root of 3 over 2. And that's going to be positive because we know angle A over 2 is in the second quadrant. Okay, next example, it says evaluate sine of theta over 2 if you know that tangent of the angle is negative 5/12 and your angle is in quadrant 4. So if theta is in quadrant 4, that means you're between 270 degrees and 360 degrees. So if I want to figure out whether I use the plus or the minus in my formula, I need to find what theta over 2 is in, what quadrant. So when I divide the whole compound inequality by 2, I get 135 as my lower limit, and my upper limit is going to be 180. So angle theta is in the fourth quadrant, and angle theta over 2, half that angle, is in the second quadrant. I'm going to label this as theta over 2 is in quadrant 2. Now we're going to make our triangle so that we can figure out what cosine is, because our formula is sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine theta all over 2. So we need to know what cosine of theta is to plug into our formula. And we're going to get that by making our triangle and using that tangent of theta is 5/12. And we're not going to worry about the negative because we're just keeping track of what quadrant we're in. So tangent is opposite over adjacent. So this is my opposite side, this is my adjacent side. And if I use Pythagorean Theorem, I'm going to find that the hypotenuse is 13. Because theta over 2 is in the second quadrant, and we're trying to find sine of theta over 2, we are going to use the positive square root because sine is positive in the second quadrant. So I have 1 minus, cosine of the angle. Cosine is adjacent over hypotenuse, which is 12 over 13. And I know that cosine of theta is going to be positive because theta is in the fourth quadrant. And in the fourth quadrant, cosine is positive. And then this is all over 2. Now I'm going to rewrite this. 1 minus 12 over 13 is going to be 1 over 13 all over 2. And then I'm going to multiply everything by 13 under the square root so that I can get rid of my complex fraction. So that's going to give me 1 over 26. So my final answer is going to be positive square root of 1 over 26. Okay, next example. It gives me some information about angle x, and it's asking me to find sine, cosine, and tangent of half x. So I'm going to set up my triangle. Here's angle x. Secant is hypotenuse over adjacent. So this is going to be 3 and 2, my adjacent and my hypotenuse side. So to find my other leg of the triangle, we're going to use Pythagorean Theorem. So this is going to be the square root of 5. So the other leg is going to be the square root of 5. Now, angle x is in the fourth quadrant because it's telling you that it's between 270 degrees and 360 degrees. So we need to figure out where angle x over 2 is so that we can figure out sine of x over 2, cosine of x over 2, and tangent of x over 2. Well, if x is between 360 and 270, so if I divide everything by 2, I'm going to get that the angle x over 2 is between 135 degrees and 180 degrees, which means x over 2 is in quadrant 2. And that's going to be important when we try to find our sine and cosine so that we can figure out if we're going to use the positive square root or the negative square root. Okay, so we have, let's do sine first. Sine of angle x over 2 is going to be positive square root because angle x over 2 is in quadrant 2 and sine is positive. So they're going to use the positive square root of 1 minus cosine x all over 2. So we have the square root of 1 minus, and we got to find cosine x to plug it in the formula. Cosine x, if we look at the triangle, cosine x is adjacent over hypotenuse, and angle x is in the fourth quadrant, so cosine is going to be positive. So I'm going to get just 2/3 in here for cosine x, and that's going to be all over 2. Now I'm going to multiply through by 3 so that I can clear the complex fraction. So I'm going to have 3 minus 2 over 6, which gives me the square root of 1/6. So sine of half angle x would be the square root of 1 over 6. Now let's do cosine of x over 2. X over 2 is in the second quadrant, so now we have to use negative square root. 1 plus cosine x all over 2 is my formula for half angle for cosine. So we have negative square root of 1 plus 2/3. We already found out that cosine of x is 2/3. I'm going to multiply through by 3 so I can clear the complex fraction. So I have 3 plus 2 over 6, which is going to give me negative square root of 5/6. So that is for cosine of x over 2. The last one we have to find is tangent of x over 2. That formula is 1 minus cosine x over sine x. We already found that cosine x is 2/3, so I have 1 minus 2/3 over. sine x, we have to look, we haven't found sine x yet, so we have to look at our triangle. Here's our triangle. It's starting to get buried in all of our scratch work. There's our triangle. Sine of angle x is going to be opposite over hypotenuse, so that's the square root of 5 over 3. And since angle x is in the fourth quadrant, sine should be negative, so that should be negative square root of 5 over 3. Now I am going to multiply through to clear the complex fraction. I'm going to multiply through by a 3. So I have 3. So I have 3 minus 2 all over negative square root of 5, which is 1 over negative square root of 5. So here's our final answer for tangent of angle x over 2. Here's cosine of x over 2, and here's sine of x over 2. Okay, last example for half angle formulas. We're given that sine of angle A is negative 3/5. Angle A is in quadrant 3, and we're going to find the secant of angle A over 2. So if angle A is in the third quadrant, that means angle A is between 180 degrees and 270 degrees. So if I want to figure out where angle A over 2 is, so I know whether to use the plus or the minus, I need to divide everything by 2. So that's going to give me 90 degrees and 135 degrees. So I know that angle A over 2 is in the second quadrant, and angle A is in the third quadrant. Now, we don't have a formula for secant of angle A over 2. However, I know that secant and cosine are reciprocals. So I'm going to find the value of cosine of A over 2 and then take the reciprocal. Because we do have a formula for cosine of A over 2. And since A over 2 is in the second quadrant, cosine is negative in the second quadrant. I'm going to use the negative square root formula. And I have to make my triangle so I can figure out what cosine of angle A is. It's given to me that sine of angle A is 3/5. I'm not going to worry about the negative because I just want to find the length of the side of the triangle. So for angle A, the opposite side would be here. Here's the hypotenuse, so the other leg is going to be 4. So my cosine of angle A is going to be, if I take the adjacent side over the hypotenuse, which would be 4/5, but here's where it gets tricky. Remember, angle A is given to us that it's in the third quadrant, and cosine is negative in the third quadrant, so I want to make sure I have a negative 4/5 there. And that's all over 2. This is why it's really tricky whenever you plug in something with half angle formulas. You want to make sure you know what angle you're looking at, what trig function you're using, and what quadrant you're in, so you can decide if you need to use plus or minus. Okay, I'm going to multiply everything through by 5 so I can clear the complex fraction. And when I finish simplifying, I'm going to get negative square root of 1 over 10. Now this is the cosine of A over 2. Remember, we were trying to find the secant of A over 2. So I'm going to write down here, cosine of A over 2 is equal to negative square root of 1/10. So that means secant of A over 2 is equal to negative square root of 10. Because I am going to take the reciprocal of negative square root of 1 over 10. So this is my final answer. In this last example, I'm going to talk to you briefly about formulas for lowering powers, and sometimes they're called reduction formulas. And it's just a way to make something that's squared in the first power, rewriting it using double angles. It's not something that we use very often in this class, but I do want to expose you to it so that if you ever do want to pull this out of your toolbox and use it for something, you've seen it before and you know that it's available to you. So in this example, it says rewrite the expression in terms of the first power of cosine. So if you notice, all of my formulas have cosine in them, which is great because that's what we're looking for. However, I don't have a formula for cosine to the fourth here. So what I'm going to do is I'm going to rewrite cosine to the fourth as cosine squared times cosine squared, so we can use this formula here. So first I'm going to rewrite this as cosine squared x times cosine squared x times sine squared x. So cosine squared x, using our formula, would be 1 plus cosine 2x all over 2. Cosine squared, I would do the same thing and replace it with 1 plus cosine 2x over 2. And then the formula for sine squared is 1 minus cosine 2x all over 2. And then you would just multiply through. On the bottom, you have 2 times 2 times 2, which is 8. On the top, you would have 1 plus cosine 2x squared times 1 minus cosine 2x. And you can FOIL that if you want, but I'm totally fine with you just leaving it like this.